Welcome back. Today we are doing lesson 17, which is on data interpretation. This is the first part of the lecture where we would do just the basics of data interpretation. So first, to give you an overview, data interpretation on GRE typically involves 3 to 4 questions. Oops. That typically involves 3 to 4 questions per section. Okay, so in total, you can expect to see up to 8 questions across the 2 quantitative sections on GRE. Okay, so that's a lot of questions, a lot of points there to take. As the name suggests, data interpretation involves lots of data. Okay, so the questions in general on data interpretation are relatively straightforward. There are not many tricks involved, but it involves a lot of calculation. So you'll have to actively convert from numbers, let's say, to percents or to ratios, things like that. So it's kind of all the concepts that you have learned up to this point can come into play in data interpretation questions. So relatively straightforward questions, but a lot of calculations. And sometimes the calculation can be tedious. There are 3 specialized ways that GRE would usually represent data with. So data representation. So these 3 ways of data representation are a line graph, a bar graph, or pie charts. So we'll look at each of these 3 ones separately. Okay, so let's start first with the line graph. So here's an example of a line graph that you might typically see on a GRE question. If you note here, this graph is basically your XY coordinate plane, right, which you have seen earlier. So you have 2 axes, the x-axis and then the y-axis, and then you have some points here, each point representing some value at the x-axis and y-axis. Okay, so the first thing you should do when you see a line graph like this is that you should read the labels very carefully. So by labels, I mean the label for what does this x-axis represent. So here, the x-axis is years, right? Or any particular year. So I should just say year. The y-axis says population in millions. Okay, so millions is important. Millions is the unit of the y-axis here. So this number means 320 millions. Okay, and the title of the whole graph says US population from 1990 to 2010. So basically, using these labels, once you understand the labels, you can get a big picture idea of what this graph represents. Okay, so this big picture is basically the graph is representing the population of US from 1990 to 2010, right? For each 5-year interval, it tells you what the population was. Okay, 1, 2, 3, 4, 5. Okay, you can infer other things that the population in general is increasing. Okay, and the rate of increase is kind of a constant too. Like you see, the slope of this line is going from one point to the other is pretty much constant, right? So it's a general increase. It's a steady increase in population at about the same rate. But this rate information you don't need to know right away. This is just an additional piece of information. Okay, so this is your line graph. Next, we'll look at a bar graph. So here I've taken the line graph from the previous example and actually put the same information in bar graph. So again, you have the population of US going from 1990. Oops, so this is not working. You have the population of US going from 1990 to 2010, and instead of those points, now you have bars, right? So a bar graph, in a way, is easier to read than a line graph because you can kind of get a hang of it maybe a bit easily. But again, it depends. Like, even a bar something can be sometimes hard to read. Also, I would like to mention that so the 1995 data point is easy to read. So population in 1995 is 305, is kind of like right at the 305 line, right? But what about 2005? The population here is kind of in the middle of 2 points, 310 and 315. So somewhere going here, right? So in this case, you just have to estimate. Just take an estimate. It's kind of in the middle, so you can say 312, 313, and go and do your calculations with that. GRE used to do this a lot. Like they would push you to estimate the bar graphs. The graphs would in general not be exact, but now they have gone like they don't do that as much. So usually your points will kind of neatly lie at particular XY value, so it will be easy to pick off, and you won't have to guess mostly. Okay. Now bar graphs can be modified to give more information too. Okay. So here is an example of a bar graph where you have the same US population, but now it's divided into two groups. So one group is over age of 50, that's the dark colored spot. And the other group is the under age of 50. So they have divided the whole US population into two groups. So if I pick 1990, about 200 million under the age of 50, and the rest, which is about 100 million above the age of 50. Okay, so in this way, you call this a segmented bar graph. Not that you need to know that terminology. It's just another way to represent actually more data than a simple bar graph can represent. Right? So usually the bar graphs that you will see on GRE would be a bit more complex than a regular bar graph. They will be segmented, there will be multiple segments. Another version is where you have a bar graph which has, for each point on the x-axis would have two bars, like this. And we'll look at examples of this later on. But in general, with these graphs, just always be careful to read the labels properly. So here you could have just maybe some year, let's say 1990, and some different data points represented by these two different bars, right? So let's say you could have the one data point could be the male population in 1990, the other could be the female population, so male, female, and you are tracking that across years, right? So 1995 would have a male population and a female population. Okay. All right, so next we'll look at the third type of data interpretation tool used by GRE, and that's called a pie chart. So a pie chart is basically a circle which is divided into different pies of whatever data set you're trying to represent. So here, my data set is basically distribution of Kim's monthly expenses. So here there are 5 categories. On saving, Kim spends 30%, entertainment 20%, food 20%, clothing 15%, transport 15%. And you'll see this should always add up to 100%. Right? Okay. On a pie chart, the data can be represented in percents as well as in numbers. So here all the data is in percents, but very well I could say that the savings is $600. So I can represent all numbers or some of the numbers, some of the fractions as numbers, absolute numbers, or as fractions or as percents. Okay. The other important piece of information that can be given is how to translate these percents, right, into numbers. So here this piece of information is important. It says the total monthly expenditure is $2,000 US. Okay, so this number is important since this can help you convert from percents to numbers or vice versa. Okay, so when we'll look at examples, we'll see how this comes in handy. Okay, another thing to note is that with pie charts, since it's circles, sometimes central angles will be involved. Central angles and using properties of circle sectors, area sectors, is something that we have done in the circle lesson. Those can come in handy here too. Okay. Lastly, to conclude this introduction on data interpretation, usually on GRE questions, you will get combo graphs. So combo graphs, I mean that you could have like two pie charts together. So one pie chart, so like two pie charts, or you could have one pie chart with a bar graph. Okay? So you will have to translate information from two different pieces of data and answer the question. So GRE makes it a bit more tedious for you. So again, it's not tricky. It's just you have to read two different pieces of graphs and then infer from those and answer the questions. Lastly, I would want to mention that you could also get data represented in simple data tables. So instead of all these graphs, you could just have a simple data. Let's say here I can draw data of college enrollment. So I have college X, I have college Y, and maybe I can just represent data on how many freshmen are there, how many sophomores are there, how many juniors are there, how many seniors are there, right? So instead of any graphical representation, it's just simple data presented here. So maybe in college X, there are 1,000 freshmen, there are 1,200 sophomores, there are 1,000 juniors, and then there are about 1,100 seniors, and so forth for college Y, right? So this is another very simple way to present data. All right, so that concludes the basic introduction of data interpretation. And in the next part of this lesson, we will do some actual examples to give you an idea of how GRE will test you on this information. All right, I'll see you later. Thanks.